Welcome to solverfy.
Okay, so this question asks us to judge the statement. So let's look at the first one. The first statement is for molecules with similar molecular weights, the dispersion force becomes stronger as the molecules becomes more polarizable. And this is right because for molecules, the interaction, if there's no hydrogen bonding, we know are determined by the van der Waals force. And in the van der Waals force, we know the dipole-dipole reaction is strongest. And its strengths are determined by the magnitude of the dipole of the molecule. So if the dipole increase, the force will also increase. And if the molecule is easy to be polarizable, right, we can actually regard the instant dipole this molecule generates will actually be larger. And so the first statement is true. And the second statement, for noble gas, the dispersion force decrease while the boiling points increase as you go down in the column of the periodical table. And I think this statement is wrong because the dispersion force, you see, this statement is contradicting with each other, because usually the stronger of the dispersion force and the larger or higher the boiling point, because the boiling point are determined by the intermolecular interactions. So this statement actually contradict with each other within the statement. So this is false. And the true statement should be, as you increase the atomic mass, when you go down to the column, actually we know the molecular mass increases and the atom actually becomes larger, right? It becomes the size of the atom becomes larger. So it's actually much easier to be polarized. So the dispersion force becomes stronger and the boiling point will also be stronger. That is the right statement. So now we can go to C. The C states, in terms of total attractive force for a given substance, dipole-dipole interactions, when present, are always greater than the dispersion force. And this statement is generally true. And you can say once there's a dipole interactions, the boiling point of a certain molecule is always higher than. And we can actually give some examples. If you look at the boiling point of the noble gas, they are actually among the lowest, and there's only dispersion force or London force existing in those noble gas molecules. However, for other molecules, as long as they have dipole interactions, they are actually much higher than those noble gas molecules. So this statement is true. And D, all other factors being the same, dispersion force between linear molecules are greater than those between molecules whose shape are nearly spherical. So, as we mentioned, the dispersion force is actually proportional to the polarizability of the molecule. So the statement is the linear molecules are greater than the spherical molecules. The statement actually tells you the linear molecule is easier to be polarized than the spherical molecules. And this is actually true. So this statement is true. And E, as we said, the larger the atom, the more polarizability it is. This is true, as we mentioned earlier, because the electrons crowd are more like dispersed in the space, so it actually can be moved much easier than the smaller atom or molecules. And this is the answer.